Great, open up your book to section 14-7. We're on page 734 in your book, and the title of this section is Functions of a Random Variable. The objective here in this section is given a random experiment. Find and graph the probabilities of all possible events. All right, so let's start out with an example here. Let's suppose that we're flipping a coin, but let's suppose that this coin is not a fair coin, that it's been bent. So because it's bent, it's a little bit more likely that it lands tail side up than it is that it's going to land head sides up. That's not 50-50. So the probability that it lands head side up is 0.4, 40%. So the question here is to find the probability that it lands head side up 2 times out of 5 flips. We're going to flip the coin 5 times, and we want to end up with 2 heads. All right, well, let's start out by simplifying this problem a little bit. And let's focus on one particular outcome here. Let's assume that we want to find the probability of getting the first 2 flips are heads and the last 3 are the tails. Doesn't really matter which one of these we'd pick, but let's pick that one because that one just seems the easiest one to start off with. So if we want to find the probability that you end up with heads, followed by heads, followed by 3 tails. Realize that this is only one of the possible outcomes where we'd have 2 heads and 3 tails. Right? The 2 heads there could be at the very beginning, they could have been at the end, they could be anywhere in between. So we're only considering one of these possibilities for right now. So we're simplifying the problem a little bit, and then we'll deal with how do we take care of all these possible outcomes there. Let's deal with just the one outcome of, well, what's the probability of getting head, followed by heads, followed by tails, tails, tails. That exact order. All right, so if I want to find that probability, I can take and break this up into its individual probabilities from what we learned in the last section there. This is really the probability of flipping heads on the first flip of the coin and flipping heads on the second flip, so that's times the probability of heads on the next flip. And these are independent events. Doesn't matter what I flip the first time, it's not going to affect the next time. And tails on the next flip, and tails on the next flip, and finally tails on the last flip. So I can rewrite this as a product of these 5 values here. And we know what these are equal to. They told us the probability of heads is 0.4. Probability of heads is 0.4. Now it either lands heads or tails. There's not anything else here that we're going to get. So probability of tails is the complement of that. So that's 0.6, 0.6, and 0.6. Or I guess we could rewrite this, since it's a repeated product here that we've got. I could actually write this as 0.4 squared, which is interesting because that's accounting for the 2 heads that I want to end up with. And then 0.6 cubed, which is interesting because that's accounting for the 3 tails that I need to account for. But that right there would give me the probability of getting this exact outcome here. Heads, heads, tails, tails, tails. Exactly in that order with exactly those results. Well, let's calculate what that's equal to. Go ahead and grab your calculator here. And if we take 0.4 and square it, and add it to, not add it to, we're multiplying it by 0.6 cubed, we end up with 0.03456. 0.03456. All right, so that's the probability of exactly this one outcome. But there are other outcomes where I'd end up with 2 heads and 3 tails. So the question is, how many other outcomes would end up with 2 heads and 3 tails? I know there's one of them. I got it written down here. Let's see if we can come up with how many outcomes that would be. In fact, let's list them here. I think it's going to be a short enough list that we can list them all. And let's start with the one that we have. We have heads, heads, tails, tails, tails. All right, let's Let's do this in order here. I'm going to just take that second head there and slide him to the right one slot at a time here. So let's say I have heads, then tails, followed by the heads, tails, tails. So I've moved that second heads over one spot there is what I've done here. Do the same thing again. Heads, tails, tails, and then heads, tails. And then finally heads, tails, 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 heads. So I've taken that second heads there and moved him all the way through. So there's 4 ways to do that. Now let's start out with tails followed by 2 heads followed by 2 tails. So I'm sliding the 2 heads over there. So now do the same thing. Slide that second heads over one spot. Heads. It'll be tails, heads, tails, heads, tails. And then tails, heads, tails, tails, heads. That gets that second heads all the way to the end. And let's do that again. Start out with 2 heads though, or sorry, 2 tails though, followed by 2 heads and tails. And slide the second tails over one spot. Or sorry, second heads over one spot like we've been doing. And I guess there's only one last combination to write, right? I could have started with all 3 tails at the beginning, followed by 2 heads at the very end. All right, so how many do we have here? 4 and 3 and 3. That looks like a total of 10 different ways that this could happen. So in our formula, we only accounted for the one, what we started with. This very first combination, we've taken care of him. All right, looks like my answer should have been 10 times as big, though, because I got to add all these probabilities up or just multiply what I got by 10, right? I could add up all 10 of these, and they'd all be the same calculation for what the probability that they occur are, or I can just simply take my calculation and multiply it by the 10. But I guess the better question is, how do I come up with this 10 here? How do I come up with what this value is equal to, so I don't have to list all these outcomes here? Well, this is actually just a combination, really, is all I'm looking at here. If I think about it, I've got 5 spots. 1, 2, 3, 4, 5. 5 flips of this coin here. 1, 2, 3, 4, 5. And I'm picking 2 of those spots to put the heads in. I'm saying, hey, what if the heads was here and maybe here? And then I'm moving around. I'm saying, give me all the combinations of heads in all these different spots. Pick any 2 of the spots that you want. The 2 and the 4, the 1 and the 3, the 1 and the 2. So this is really just a combination. This is 5, choose 2. You've got 5 spots to pick from. Pick the 2 to put the heads in. The other 3 will be the tails. And 5 choose 2 is in fact equal to 10. That is critical for us to understand, so that way we can easily figure out then how many of these different ways of arranging these 2, in this case, 2 tails, or sorry, 2 heads and 3 tails are going to be. Let's put all that together then. What did we just figure out? The probability of getting, 2 heads in 5 flips, my goodness. Turns out it's equal to, it's the 10, which is actually 5 choose 2, 5 choose 2, times the probability of getting heads, the 2 heads there, that was 0.4 squared, we said, times the probability of getting the 3 tails, that was 0.6 cubed, which we've already calculated this guy here at the end. That was the 0.03456. So if I multiply by the 5 choose 2, multiply by 10, I'm just sliding the decimal place over 1. So we can do that. 0.3456, it looks like, is the probability of getting 2 heads in our 5 flips. There's a 34%, almost a 35% chance that that's going to happen. That right there is the foundation for the formula we're talking about in this chapter, or excuse me, in this section. The probability of a function of a random variable. All right, so let's talk about a binomial experiment, which is what we were just talking about here. But a binomial experiment is a random experiment in which there are only 2 possible results. That's why it's binomial. Only 2 possible results. So here we're flipping a coin. It's either heads or it's tails. You are shooting hoops and you either make it or you miss it. You're rolling die and you either get an even number or an odd number. You're talking about something where there's only one of two possibilities here. Binomial experiment, random experiments, there are only two possible results. The other two results you could be talking about is either the event occurs or it does not occur. There's another way of thinking about it. You could actually think of almost every event as being a binomial experiment as long as you think of it in the form of it occurs or it does not occur. And finally, a binomial distribution, which some of the problems are going to ask you to sketch a binomial distribution. But a binomial distribution is a function that shows the probability of every possible outcome of a random experiment. The function that shows the probability of every possible outcome of a random experiment. So if you're rolling die, then you're finding the probability of getting a 1 and the probability of getting a 2 and the 3 and so forth. All the way up to a 5. Or sorry, all the way up to a 6. All the possible outcomes. That's what a probability distribution is. Function that shows the probability of every single one of the possible outcomes. All right. So this leads us to that first example there leads us to what is called the binomial probability distribution. We'll deal with each one of these parts here in detail here, but this is the formula that we just came up with. The probability of an event E occurring, in our case the event was flipping heads on this coin, occurring X times, in our case we wanted to have 2 heads show up, in N repetitions, that was we were flipping the coin 5 times. So again, make sure you understand what this is saying here. The probability of your event E, that would be flipping heads on the coin, occurring X times, you want to get 2 heads, in N repetitions. We were flipping the coin a total of 5 times. Here's the formula. P of X, probability of 2 heads, is equal to N choose X, ours was 5 choose 2, times P of E raised to the X power, the probability of getting heads was 0.4, raised to the 2nd power because we wanted 2 heads, times the probability of not that event. Again, it's got to be binomial, so it either occurs or it does not occur. So the probability of not E raised to the N minus X, that was probability of probability of tails, was the 0.6 raised to the 3rd power. 3rd power was the 5 minus 2. Right there is our general equation there for finding one of these binomial probability distributions. And just so we're clear on what all these represent, here's what each of those mean. The P of E is the probability that this event occurs. So again, in our case, it was the probability of flipping heads. It was a bent coin, so it was only a 40% chance of that, so that was 0.4. X is the number of times that event E occurs in those N repetitions. So we wanted to get heads 2 times, so X was 2. And the number of repetitions, N, was 5. We were flipping the coin 5 times. And finally, P of X is the probability that event E occurs X times in N repetitions. So the end result there, the P of X that you see over on the left, the P of X is the probability that event E occurs X times in N repetitions. So that's our little formula that we're going to use to actually calculate a binomial probability. Let's try that out. Take a look at example 1 there. Still dealing with this bent coin problem here, actually. So part A here says, well, first of all, it says a bent coin is flipped 5 times. The probability of getting heads on any one toss is 40%. So same problem that we were starting out with. Part A says find all the terms in the probability distribution. So all the terms in your probability distribution. Sometimes writing this out in kind of in a table form is a nice way to do that. But let's first define the function P of X. P of X is equal to It's n choose x, so it's going to be 5 choose x. I'll leave it in terms of x there, so that way I can plug in 0 and then 1 and 2 and so forth into this equation. Times the 0.4 raised to the x power. And then times the probability of not that would be 0.6 raised to the n minus x. That's going to be 5 minus x power. Right here is our little formula that we can use then, our little equation that we can use to actually come up with this binomial distribution, this probability distribution. It is binomial as well. But let's create a table of values. So if I'm flipping the coin 5 times, there are 6 possible outcomes here. I could have 0 heads, I could have 1, I could have 2, 3, 4, or all 5 could end up being heads. That's all the possibilities. So we'll fill in these values here in our table here. To do that, though, let's grab our calculator and let it help us out here. We're going to take that equation that we have and put that into y1. So let's do that. Grab your calculator and let's try this out. All right, so go to your y equals menu, and let's put in our equation, the same equation we just wrote down, p of x. It's 5 choose x, so 5, and then go to your math menu, and you can grab the combination function, 5 choose x. I'm going to put that in parentheses here, actually. And then it's 0.4 raised to the x power. And then we're multiplying that by 0.6 raised to the n minus x power. So that's 5 minus x power. There's our little equation. Let's go to our table. Actually, go to the table setup first just to make sure it's set up correctly. You want to start out at 0. You want to change by 1 and make sure it's going to automatically generate the table for us. And now when we go to our table, here is the values that we're looking for. The probability of getting 0 heads is 0.0778. Probability of just getting 1 head is 0.2592. Probability of getting 2 heads is 0.3456. That should look familiar. That's the problem we started out with. That's our probability for getting 2 heads and 3 tails with our bent coin here. All right, let's grab a picture of this. And we'll fill in our table here. So it's 0.0778, 2592, 0.3456. Again, that's the one that we already calculated. 2304, 0768. And the last one, 0102. Now, if you wanted to actually graph that or sketch what that looks like, they didn't actually say to sketch it here. They actually asked us to do this in part C. So we're jumping a step here. But if we want to sketch what this looks like, let's go back to our calculator and do that. And if I go to my y equals menu, to do this really, to sketch it correctly, what I need to do is I need to put this data into a list. All right, if you try to sketch this in your standard window here, when I graph this, I don't really get anything, okay, because I'm trying to plug in all kinds of weird numbers into this. All right, so really to sketch what this looks like, I need to get this data dumped into a list. So let's do that. So in list 1, I can go to my stat menu and go to edit. Let me just clear out my data I've got here. I'll clear out all these lists. All right, in list 1, we're going to put in our 6x values, 0, 1, 2, 3, 4, and 5. And then actually you can come up here to list 2, to the name of list 2, and you can type in to evaluate y1 at each of the values you see in list 1 there. And I can do that by going to my variables menu, going over to y variables, going to function, and grabbing y1, and then in parentheses, typing in list 1, second, and then 1 will get me list 1. That's going to take and plug in all the values that I have over there in list 1 into my function in y1, and then give me the same table of data that I saw there on my table a second ago. But now, since it's in a list, I can do a stat plot with this. So now go to your y equals menu. I'm going to just shut off this equation for the moment. I guess it's not going to sketch anything anyways, but I'm going to shut it off anyways. And go to my stat plot. I'm going to turn on plot number 1. I'm going to just do a scatter plot there using list 1 and list 2. You can change the color and the mark if you want to, but I'm going to leave it as is. I'm going to change my window here slightly because I know that I'm only going from 0 to 5. But actually, I'm going to go from -1 to 6 just to give me a little space there around my sketch there. And for my y's, I know these are all really small numbers. I just looked at the table of data. The biggest one was the 0.34 something, right? So I can sketch this, say, from 0 to 0.5 is probably a decent window to sketch this in. And when I graph this, there is my probability, the graph of my probability distribution. In fact, let's grab a picture of that. And we'll paste him in here. Let's call this part C. Again, we jumped over step, or part B there temporarily here, but we'll put in part C right now. Part C is this sketch that we just made here. All right. Let's go back and answer part B now. Part B on this problem said, show that the total of the probabilities equals 1. And explain the significance of this fact. Again, putting this into a list made this a lot easier for me to do as well. But if you go to your calculator again, and go to your list, I've got the data in list 2. And with the data in a list, I can sum up that list really easy. So if I go to my list menu, second list, over to math, there's a sum feature in there. And I can say to sum up list number 2. And I should get a value of 1. That's what we get. And as far as what's the significance of that, well, remember that if the sum of these probabilities is 1, that means I've accounted for all the possible cases here. Which should make sense. When you're flipping a coin 5 times, you either get 0, 1, 2, 3, 4, or 5 heads. There's no other options. I'm guaranteeing you that when you flip the coin, one of these 6 outcomes will happen, is what this means. Some of these probabilities turns out to be 1. Let's go ahead and write that down on our page here. So for part B, to write this down, we have P of 0 plus P of 1 plus P of 2, and so forth. P of 3, you could use a ... here to indicate this keeps going here, but I'll go ahead and write them all out. Plus P of 5. If I add all those up, it turns out it's 1. Exactly what I would expect. Flip a coin 5 times. These are the only 5 possibilities. You either get 0, 1, 2, 3, 4, or 5 heads as a result. All right, last part of this one. Part D, it says calculate the probability that the coin lands heads up at least 2 of the 5 times. Threw the word at least in here again, so be careful with that. Probability of at least 2 heads. So you again have a couple of ways that you could go about calculating this. And you can decide which one you like best. I'm going to do it one way, but there's no reason why you have to do it this one way. But I'll show you both calculations you could do. One way you could look at this and say, well, if you got to get at least 2 heads out of the 5 flips, that means you could end up with 2 heads, or you could have 3 heads, Or you could have 4 heads, or you could have 5 heads. Again, the key word there is or, so I know I'm adding those up. But I add up the probabilities of 2, 3, 4, and 5. That's one. Oops, I didn't need to write H in there, sorry. The original one I needed it, but this is using, I'm talking about that P of X function up above there. Let me just get rid of that. So that's taking that P of X function and plugging either, in 2, 3, 4, or 5 into it. That's one way you could do it. The other way you could do this is to think about the complement. This first calculation wouldn't be too bad to do, but actually you're doing twice as much work as you really need to, because if I think about it in terms of the complement, it's 1 minus the probability of no heads or 1 head. That might be a little bit easier to calculate. And in fact, I'm going to use my calculator again to do this, since I have the equation in y1. I've also got the data in my list, so I could do it that way. There's actually several ways at this point I could do this calculation on my calculator. We'll do it one way here, though. So if I take, since I have the equation in y1, I could tell it to take 1 minus, I'll put this in parentheses and evaluate y1 at 0 plus y1. Again, go to variables, y variables, function, y1 at 1. Again, I'm just using that function p I've already defined in your y equals menu and writing the calculation the same way I have on my slide there. What do we end up with? 0.66304. So let's write that down, 0.66304. There's the probability of at least 2 heads as a result. That right there is the end of section 14-7.